So good afternoon, everyone. Welcome. Delighted to have you here this afternoon for our Civic Scientist lecture with Bill Press. Civic Scientist program includes this lecture, but in our Civic Scientist program we also have a STEM education outreach, and we have a lot of policy research going on, which we're happy to tell you about, but on another occasion. Our lecture series hosts prominent scientists in all fields of science and engineering who've made significant contributions in their fields of research and have devoted a portion of their careers to public engagement, broadly defined, inside government, outside government. The goal is to encourage others to follow their good example, and more generally, the goal of our program is to promote a much-needed dialogue to bridge the divide that continues to grow, I would say, between science and rational public policy making. Still have trouble with that word rational, but bear with me. Apologize for the catty remark. But how scientists can most effectively engage the public is a challenge, and our speaker this evening will cast some light on that question. The Civic Scientist program would not be possible without the generous support of our sponsors. The program has received enthusiastic support from our Rice co-sponsors, the George R. Brown School of Engineering and the Weiss School of Natural Sciences. And we want to give special thanks to Benjamin and Winifred Cheng for their continued and considerable support of the Civic Scientist program. To introduce our featured speaker is the chair of the Physics and Astronomy Department, my colleague Doug Natelson. Dr. Natelson is a professor in applied physics and electrical and computer engineering, as well as material science, nanoengineering. His research specialties, in his research, he specializes in electronic, magnetic, and optical properties of nanoscale structures, which he perhaps won't have time to tell you about, but you can ask him later. He received his PhD from Stanford University, studying under Doug Osheroff, a Nobel laureate, who was the discoverer of superfluidity in helium-3, I think you will know. And he did his postdoctoral work at Bell Laboratories. So please join me in welcoming Dr. Doug Natelson.
Thank you, Neil. Good evening, everyone. It gives me great pleasure to be here and introduce Dr. Press. Bill Press currently holds the Warren J. and Viola M. Raymer Chair in Computer Science and Integrative Biology at the University of Texas. This is an indication of what a remarkably diverse scientific career he's had. It's been incredibly broad and varied. He's routinely been a person ahead of his time. The way you can tell this is that he got his doctorate at Caltech in the early 70s under Kip Thorne, and the two of them together wrote a review paper called Gravitational Wave Astronomy in 1972. And for those keeping score at home, gravitational waves were first unambiguously detected about a year ago. So if you publish a review paper about something 44 years before it's discovered, that's pretty good. He's done work he's done scientific work directly related to at least two major discoveries. One, really major discoveries. One that one, and his PhD progeny, Adam Rees, shared the Nobel Prize for the discovery of the fact that the universe's expansion is continuing to accelerate. As I said, he's had a remarkably varied career. He was a very young tenured faculty member at Harvard before he went to, eventually he went to become the deputy director at Los Alamos at a very exciting and turbulent time. Throughout his career, and then he went to the University of Texas, where he kind of shifted gears in terms of research from general relativity and gravitation to computational biology. He's had a broad impact on many people. He may not want to hear about this anymore, but one of his most educationally impactful things is he's the lead author on a book called Numerical Recipes, which taught many people how to do any kind of computational science at all. I wrote a book too, and if my book is on sale for about 250 years, it might sell as many copies as his book. He's been very, very active in public policy, for a long time. He's a member of the National Academy of Sciences. He's a member of the American Academy of Arts and Sciences. He's a member of the Council on Foreign Relations. He was the president of the American Academy of Science. The Association for the Advancement of Science. And he spent 8 years as the vice chair of President Obama's Presidential Council on Advisors in Science and Technology. So he's truly a citizen scientist, and I very much look forward to hearing what he has to say. Dr. Press.
Thank you, Doug, for that kind introduction in which I almost recognized myself, but not quite. But I want to give you a small number of facts and a rather larger amount of interpretation of those facts. Interpretation is something that any of you can do. I hope that we'll have a long question period in which your views can be made known. Let's see, which button do I push? No, not that one. There we are. But I want to start by pointing out that in the scientific enterprise, we often describe it to other people with storylines. So here is, I think, our number one storyline. It says that scientists are motivated by a goal of pure discovery, are curiosity-driven. We observe, we measure, and we characterize some new phenomenon. There are other scientists and engineers who are motivated by a different desire, a desire to create new applications, to develop technologies and inventions, to found companies, utilizing this new phenomenon. And the result of this are new products, jobs, and industries. Okay, so this is a storyline which luckily, both for the scientists and for society at large, is pretty much true. And to show you a little bit of evidence of this, this amazing graph, I should tell you that I just became, about a year ago, treasurer of the National Academy of Sciences. I was elected by the membership. So suddenly I need to understand high finance. And well, it's hard. But I thought this is an amazing plot which shows that for 120 years, the growth in real GDP per capita, that is how rich on average is the average American, actually not the average American, but how rich on average is the American, and also what has been returned on the S&P 500 as an indicator of the rate of growth. And this is on a log linear plot, and so a straight line means exponential growth. And what's amazing to me is that we've seen this on this kind of scale, so perfect exponential growth for 120 years. Now, I need to point out in the inset that a lot has been written about whether in the last 20 years this represents a fluctuation or an actual change in the rate of growth. Okay, that would be some other talk by an economist. The other thing I should point out that is also not quite in my talk is I've scaled the rate of growth to be on the same line here, but real GDP per capita has actually grown at a rate of 2.3% per year. Well, over 120 years, that's quite a lot. Whereas the S&P 500 has grown at 6.46%. So I'd give you as an aside this difference in how we value, roughly speaking, labor versus capital maybe is part of the price we're paying today in terms of our politics. However, that's not what I want to talk to you about. What I want to talk to you about is science's contribution. Well, from the 18th century, the economists have tried to identify what factors produce the kind of growth I've shown you there. And the traditional ones going back literally 200 years are land, labor, and capital. Now, a more modern treatment would broaden that, so labor is not just people, it's how educated those people are, it's what do those people bring to the marketplace, that's often called human capital. Capital is not literally smokestack industries, it also includes copyrights and patents and intellectual capital. Okay, that is all well and good. But what has been studied for now probably 50 years is what's often called the Solo Residual. And that's the fact that roughly half of all the economic growth I showed you on the previous slide cannot be attributed to any of the factors on the left, but is attributable only to this factor on the right that we call technological progress. Okay? And this is the real basis for saying that our storyline, that science actually produces something, is true. You don't just have to believe the scientists, you can believe the economists. Are you any happier with that? Well, at least it comes from two different sides. Okay, so what do I conclude? I could just walk out now. I'm done. The public should be grateful to us, right? They should be grateful, and they should listen to what we say, because we're the experts on this kind of stuff, and we've produced at least half of all of this growth. But you're laughing because somehow you know that the public isn't grateful to us. No, they're not always grateful to us. In fact, the first thesis I put forward is listen to the experts is no longer an effective communication strategy for scientists. It worked for a long, long time. Now, I got woken up to this when I opened, I'm ashamed to say that I read the Wall Street Journal, but I do. I opened the Wall Street Journal. It was also in USA Today. That would make me even more ashamed. Okay, and I saw this full-page ad from the American Chemistry Council, which is a trade organization. And it said, listen to the science. Experts say BPA is safe. Okay, BPA is, you know, this additive to plastics. So first of all, when you really look at this, you know, this is one of these things that's not even true and not even false. The reason the EPA says BPA is safe has been largely because manufacturers have voluntarily taken it out of products in which there was some possibility that it wasn't safe. And since, for example, baby bottles. And since they took it out of those products, we don't really know if it was safe, but the EPA basically says it's safe in its remaining uses. Well, that's not what this headline says exactly. I thought that the only way that this could be less effective would be if instead of showing an Erlenmeyer flask with earmuffs, whatever that means, it showed a picture like this. Okay, because whoever wrote this ad was really thinking, listen to the experts, you know, the scientist in the white lab coat. The public should be grateful and they should follow our advice. Okay, so that got me thinking a lot about why this doesn't work and what would work and who is at fault here. Is it the scientists or is it the public? And that's the kind of thinking and analysis, I shouldn't really call it that, interpretation that I want to share with you here. Okay, so here's some more. I promised you a few facts. Here's some more objective evidence that the public does not think the way scientists think. This was a Pew poll that was reported in National Geographic in 2015, okay, which asked a bunch of questions of scientists and of U.S. adults generally, and found this agreement gap, as they call it. Now, look at these questions. Is it safe to eat genetically modified foods? Scientists, 88%. U.S. adults, 37%. You know, they're not listening to us now. Are we right? Are we wrong? Who's right here? But the gap exists. Climate change is mostly due to human activity, 87%, 50. Okay, here's one that really hurts me as now a computational biologist. Humans have evolved over time, 98%, 65%. I bet in the last 2 years this has moved down. Also, I want to know, who are these 2% of scientists? Okay, but still, this is troubling. This is either telling us something about public education or something about disbelief of science. I'm going to come back to this. Now, here are some interesting questions. Who favors more offshore drilling? A smaller gap. Scientists generally favor. No, I'm sorry, I have it backwards. The public is more in favor of offshore drilling than scientists. childhood vaccines should be required, okay? Scientists, 86%, 68%. It's worth thinking about where the other 14% of scientists are on this. I'm going to come back to that. Favor increased use of fracking. Okay, pretty close on that, and low numbers. This is the right place to ponder that question. Space station has been a good investment for U.S. Okay, we can think about each of these, but the thing I also noticed is that these questions are a funny mixture of being about scientific fact, on the one hand, and on the other hand, being about the opinions that scientists happen to hold. Okay? So in particular, the first three are about scientific fact. The second three, how many? Four, are about opinions that scientists hold, in which I don't really know whether a science education qualifies me in any special way to have an opinion on am I in favor of increased use of fracking. There are a bunch of considerations in that. Some are technical, some are economic, okay? Similarly, space station has been a good investment. What a funny question, okay. So as I came to think about this, I realized that there's an awful lot of confusion of what is scientific fact and what are the opinions widely held by scientists. And that's what I want to tease apart a lot in this talk. So here's another storyline that we tell about the scientific enterprise. Scientists familiar with the data recognize a danger or hazard to the public. They convince the public that action is needed, often despite opposition from economic interests or people who disagree with the evidence. Okay, the result is appropriate action by government and favorable outcomes for the public. Why are they always favorable? Because I'm telling a story here. This is a storyline. Okay, we believe this. Now, I must say, I don't think I'll take a vote on this one. You're going to have to vote on something in a little couple of minutes, so I just want to warn you. But I think probably we all believe storyline number one, and probably a big majority of us in this room believe storyline number two, but not with the same level of belief, okay? But, you know, I would say this is a more or less true story about the scientific enterprise. This is not alternative facts. Okay. But here I want to point out that these storylines are very different. Storyline number one, about enabling research, discovery, invention, and development, is about expanding the horizons to the public of what can be done using science. Whereas storyline number two is about educating the public, advocating for action and change, and that's about what should be. Okay? And these are both important roles for scientists. I'm not saying, don't get me wrong in this whole talk, I'm not saying that scientists shouldn't be out there talking about what should be, but it's a different kind of discussion from a discussion about what can be. And however obvious it is to us in this room, whether we're scientists, whether we're the educated public, whether we're the 1%, whatever elite you think we belong to, and I assure you the people in this room all belong to some elite, should is fundamentally a matter of opinion. Okay, so this is a very slippery slope once we introduce should and opinion. Here are going to be two different versions of that same storyline number two. This was the version you already saw. It's the life preserver. A hazard exists. It's mitigatable by technology. That's our special role as scientists, and so it should be mitigated. Okay, now here's one that seems very close. A new technology exists. It can make lives better, and so it should be widely adopted. Okay? Now, have I given you enough background so you see that these are really quite different? They're sort of, you know, they're almost the same, but they're not the same. And in fact, the second one is sort of It's story 2 trying to masquerade as story number 1, is the way I would say it, having given this background to it. Okay? Story number 1 was about technological progress. But if a new technology can make lives better, that's actually about a lifestyle choice. I really hate to use a word like lifestyle, but I don't know a good synonym. Because better lives, however obvious it may be to us, is fundamentally a matter of opinion. So now I'm going to let you vote on something. I'm going to give you 2 views on genetically modified organisms. Okay, you could think of them as the tomatoes down at the bottom here. And these are both reputable views, and in particular, they're views that I actually collected in the wild. That is to say, I heard them from reputable scientists. Now, I've sharpened them up a little bit for purposes of the vote, but here's the first view. GMO labeling, which, as you see at the bottom there, is scientifically misleading. It creates externalities with identifiable costs, such as higher food prices and poorer nutrition in the developing world. It sets a precedent for anti-scientific public policy. Punchline: governments should discourage GMO labeling. Okay, that's position number 1. Here's position number 2. GMO labeling is a matter of consumer preference. As long as GMO labels are not designed to be intentionally confused with safety labels, science and scientists have only a limited special role in this debate. Okay, now, this is what I think the pollsters call forced choice. You may not completely agree with either of these statements, but you should each select one that more approximates what you think. Okay, don't be shy. Everyone who agrees with number 1, please raise your hand. Okay, don't look around for how your neighbor's voting. Everyone who agrees with number 2, please raise your hand. Oh, that's really interesting. It looks to me like it's about 1/3 number 1 and 2/3 number 2. And in other scientific audiences, I've seen it the other way around. So I've learned something about Rice University. I don't know what, but something. Okay, it doesn't really matter whether it's 1/3, 2/3, or 2/3, 1/3. There's a point here, and the point is, this is a debate about values, not a debate about science. Okay? Now, the question that National Geographic polled on was not this question. It was, are they safe to eat? And that's a scientific question, okay? This is not a scientific question, but there are a lot of scientists who are spending a lot of energy pushing number 1 as if it were a scientific fact and not a value choice. By the way, I happen to believe in number 1, so I'm in the minority in this crowd. Okay, so I think I've drummed in this point, but let's just sort of list a whole bunch of perils of this word should. It's a matter of judgment. Whose judgment? Whoever someone is. Are people like me represented in the process? Do scientists have or claim, or should they have, a special role in judging? Okay, and now what's always very important but not always obvious is whose ox is being gored, at what cost and to whom. Is it disruptive to established economic interests? Does it imply a redistribution of wealth, which some of us might think is good, but is certainly a matter of opinion, not a matter of science? Does it imply a perturbation of political influence? And, you know, at some more abstract level, by whose moral compass? Because anyone is entitled to stand up and say, my values are different from yours, my priorities are different from yours, my beliefs are different from yours, my tolerance for change is different from yours. Okay? And we as scientists can't assume we know the answers to these questions if we're trying to communicate to the public. So, how successful have we been, looking back a long way, about a century, you'll see, in influencing the public on issues dominated by science and technology? And here I've just listed a bunch of issues, and then you see the color code. I've given just my assessment, and we could debate each one on were scientists successful? Is it ambiguous? Or did we fail in convincing the public? And first, let's see a list of ones that are in this storyline of mitigating hazards. So I'm going to go all the way back to fire safety and tell you a little bit about that, which is more than a century ago. Food safety, which is the better part of a century ago. Building codes. Tobacco, the fact that people still smoke, but generally it is accepted that smoking is very bad for you. Pesticides, air and water pollution. Okay, that was my list of greens. I have to say, just events, in the last year or so made me add a yellow question mark after air and water pollution. We're going to see what happens to EPA on those kinds of issues. Vaccination, childhood vaccination. Gosh, I would have thought 5 years ago, 10 years ago, that was a settled issue, that I could color it green and be done with it. But I think realistically now, one has to color that yellow with maybe a green question mark, but maybe it's yellow tending towards red. Climate change, certainly yellow. Antibiotics overuse, I'm thinking particularly in the agriculture industry, okay? Cybersecurity, so those are ambiguous. Those, I don't think we've failed, but I don't think we've succeeded in those. And then making better lives, I think, is red and yellows. Nuclear power, convincing the public that nuclear power is good for you. I bet there's division in this audience on that. I happen to think nuclear power doesn't produce carbon, it's alternative energy. It could have been done better, but it doesn't matter. I think we've lost that one with the public. GMOs, which you voted on, in my assessment, I think we've lost that with the public. Chemicals, this is better living through chemistry for those old enough to remember that slogan. Boy, can you imagine how that slogan would fly today? Clean energy, big data, peer-to-peer economy. I think these are all ambiguous. So, you can, in the question period, tell me I have some of these color codes wrong on particular ones. But I think overall, we just haven't done all that well in convincing the public of the views that most scientists would share on these issues. So I'm going to go back all the way 120 years, well, let's see, 100 and almost 40 years to the Chicago fire of 1871. Okay, now what am I graphing here? I don't know if you've ever looked at Google Ngrams. Google went out and, with some controversial interpretation of copyright law, scanned all the books that were ever printed, okay? And Google Ngrams, you can type in any words or phrase, and they'll tell you how often that word or phrase appears as a function of year in the entire corpus of published literature, books, magazines, newspapers, everything. Okay. So in blue, you see, you have to sort of pick reasonable phrases, are fire protection plus fire safety. And you see that until 1880, no one ever used those terms. And in the 20 years between 1880 and 1900, they started rising. And then there was the Iroquois Theater fire in 1903, the San Francisco earthquake in 1906, which of course killed more people in the fire, far more in the fire than in the earthquake, did more damage in the fire. And notoriously, the Triangle Shirtwaist Fire in New York in 1911. And suddenly, fire safety is on the agenda. And you can see building codes, a different set of events rising somewhat later. Okay. So I know it's not exactly high-tech as viewed from today, but at the time, fire safety was controversial, and it was technological. So looking back at that history, I find that there were 4 factors that all needed to come into play before we could have today's building codes, okay? Sounds very low tech, but here they are. Okay, the hazard had to be familiar to the public, okay? The public had to be able to think, this could happen to me. I could burn up in a fire in a theater, okay? There were catalyzing events. This is a picture of the San Francisco earthquake, or rather of what San Francisco looked like as the fires were burning after the earthquake. Here's where technology comes in. There were effective and affordable mitigating technologies. And interestingly, this was a great invention. My wife said I should show this picture upside down so you would recognize it, because these things come out of the ceiling, okay? It turns out it looks funny upside down because the lighting is coming, this particular picture, the lighting is coming from the wrong thing. Okay? This was somebody named Grinnell. Great invention. Namely, he developed a glass that melted at a sufficiently low temperature but was sufficiently strong enough against the pressure, okay, that it could hold back the full pressure of a water system and melt as a sprinkler head in a fire. Okay, great technology. And I think it was an important factor, I'm going to make this case to you, we can debate it, that economic interests were not exclusively against the change. And in this case, UL, I bet you see that label and nobody even remembers what it is, Underwriters Laboratory. That goes back to 1894. That was the insurance companies deciding that there should be fire safety because they wanted to make more money or lose less money paying off on huge fires, okay? And that was a change until they started, Underwriters Laboratories, until they started testing things and imposing these things on their insureds. The economic interests were not against this change. We're all against this change. If you owned tenement blocks, you didn't want to be told that you had to put in some expensive fire safety system, whereas now you do it. Okay, so here are some interesting questions we can ask. First of all, are catalyzing events always necessary? Because, Neil mentioned rational policymaking. Rational policymaking, you would think, wouldn't require catalyzing events. But gosh, when I look back at that whole list of things, it sure looks to me like we only got action when there were catalyzing events. Triangle Shirtwaist in fire safety, Silent Spring in terms of the founding of the EPA in a Republican administration, okay? Surgeon General's report on smoking. It didn't matter whether anybody read the Surgeon General's report. It came out there and it was catalyzing, okay? So this is not exactly doing science. This is interpreting of history. I think that catalyzing events are necessary. Let's look at that case study on smoking, and let's try those same 4 factors. So is the hazard, or was at the time of change, the hazard familiar to the public? Sure. Everybody knew what smoking does. Everybody had seen people die of lung cancer. Have there been catalyzing events? Well, I would say the Surgeon General's report is really what you can point to on that. Are there effective and affordable mitigating technologies? That's easy. You can just say, yeah, give up smoking. But you could say nicotine patch. You could say interest of the healthcare industry in helping people to quit smoking. And our economic interests not exclusively against change. Because originally, of course, they were, because the vocal economic interests were the tobacco companies, and there was no one countering that. But gosh, when your life insurance company started asking you, are you a smoker? And you get a much higher rate for your life insurance if you've smoked, okay? Again, it's the insurance companies. I don't know why the insurance companies emerge as heroes in a lot of these stories, but they do. Then why did my home insurance just go up by a factor of 2? I don't know. Okay, I think insurance companies came around, and I think healthcare providers came around in terms of smoking and tipped the scales on that factor. Okay, let's do one closer to home. Let's look at climate. Is the hazard familiar to the public? Well, we could take a vote. What do you think? I think increasingly, but I don't think we're there yet. And if anything, the political events in the last year have been backsliding on that issue. Have there been catalyzing events? probably. I colored that green. I think, everybody who lives on the East Coast got woken up by Hotel Sandy. Everybody who lives in the mountain and west states has been waking up to wildfire damage. I don't know what's been waking us up in Texas. It's just getting a little hotter. Drought, yeah. Right now we're not in drought, So, okay, but I'm coloring that one green. Are there effective and affordable mitigating technologies? Probably, but it's a matter of debate. Are economic interests exclusively against the change? I think that's starting to change. Again, I think you're seeing it in underwriters and insurance companies who are insuring against fire damage, against hurricane damage. Certainly as they calculate premiums, climate change is a very real part of their calculation. And large corporations now take for granted that they'd better be planning their operations, their supply chains against climate change. So that's starting to happen. But I have to say, looking at this, the conclusion I draw is we have work to do on these things. We're not there yet. We probably overestimated where we were in convincing the public on either these 4 factors, or in whatever your own set of necessary factors are to really catalyze change. Okay, the big moose head in the corner is always this. Economic interests are not passive players. They can and do actively promote distrust of science. And this is a pretty new phenomenon, okay? This is something that somebody invented. When? In the tobacco wars. And of course, if you haven't read Naomi Oreskes and Eric Conway's book, Merchants of Doubt, it's your assigned reading because it's a carefully researched and very scary story that these things don't just happen, people make them happen. And what are these things? Well, the engram I've plotted here is growth. You could pick any number of phrases and they all have this pattern. Growth in the public discourse, as measured by Google's scanned literature, of phrases like government conspiracy, like do not trust scientists, like fact versus opinion. It's not fact, it's just your opinion, that kind of a phrase. And these all kind of take off in the 1980s, in the period of the tobacco wars. Okay. I'm not really doing the social science, political science necessary to prove that. The facts of the case are what was actually done by economic interests, and that, as I say, I refer you to the Oreskes and Conway book. Okay, so let me try to sort all this out as I try to sort it out in my head. I think it becomes a lot clearer if we accept that we use the word science to mean 2 quite different things. And maybe you didn't think before that they were different, but I want to convince you that they're different. So number 1, and it's going to be blue lettering below, science is a fact-discovering enterprise. Number 2, science is a rationalist, Neil, thank you, approach to life. Now, let's talk about number 1. It's a fact-discovering enterprise, and what are the pieces of that enterprise? We believe in quantification. We believe in experimental validation. We believe in repeatability. If it's not repeatable, we don't believe it. We believe that there are underlying natural laws. We believe that even with imperfect data, one can do statistical inference and draw firm conclusions. Not just always pointing out the outlier and saying you don't know what you're talking about. There are a whole bunch of processes of the scientific enterprise, whether it's open publication or peer review or something as simple as advancement by merit, okay? We believe that this is sort of story number 1, that there's a translational path from this fact-discovering enterprise to applications. Okay? And so this is our methodology. What about number 2? Now, I have to tell you, I bet most people in this room are going to believe the second column every much as we believe the first, but it's a different kind of belief. We believe that decisions should be based on data. Okay? How could someone not believe that a decision should be based on data? All kinds of ways. Somebody I trust told me. Okay? It's my religion. You know, I'll let you extend the list. It's just that this is not tautological as much as we may believe it. We believe in, who are we? We is sort of me, right? But I'm pretending that I speak for all scientists everywhere, right? I believe in weighing pros and cons. Okay, that there's some kind of calculus of, on the one hand, on the other hand. You know, not everybody believes that. Some people believe that certain things are non-negotiable, and if there's even one of them that occurs, then that controls the decision. We're skeptical about the use of untestable facts or assertions based of authority only. Okay? I bet that almost, if not all of us in this room, share some version of a utilitarian metric, that we should have policy that is, you know, the classical utilitarian is the greatest good for the greatest number. Well, there's some trade-off involved in that, but some version of that. Okay? And I think this is one that is often unspoken, but it's very fundamental. We believe somehow in the efficacy of action. We believe that the future can be different and better. Now, that seems obvious until you look at all of human history, in which 99.99% of people throughout all human history never believed that the future could be different and better from the present. Okay? So, in fact, we're historical outliers in that particular belief. But what's my point in this list? My point in this list is that this is a value system. Okay? It's not a methodology. It's not a fact. It's a value system. It's my value system. So what can we do? I want to have 2 slides. And here, this is where we could have, you know, a long discussion about this if we want. I think where we is either scientists or people who are in a general sense part of the scientific enterprise, I think we could more clearly separate fact-based conclusions from value-based judges, even if they're both valuable. And if you wanted to know how would I actually implement, what would you actually do? Well, I tell scientific journals that they should publish more opinion pieces, and they should be labeled opinion, okay? And they should be good, rational pieces. And they should, at the same time, really go through the refereed literature and exclude statements that are fundamentally should statements in refereed publications, because that's not done today. You can just find an awful lot of it. I think that we scientists and you know, people who relate to the scientific enterprise should more actively communicate the merits of a rationalist approach to decision making, and that has nothing to do with whether it's scientific decision making or science or just public policy generally. And we do that as citizens. We do that by our own activism in the public space. We could certainly do that by influencing education. Scientists, for all the people not listening to us, we are a respected profession. And it's reasonable to say that in public education, especially in early grades, the question could be asked, how would a scientist approach this policy decision, this problem? And why would that be a good way? Or why might it not be on some issues that are really not science decisions? And I think we should be careful and selective in invoking science as a privileged platform. Okay, the worst is, you know, remember the picture of the man? This data shows that we need to X, because data never shows that, because that's a value judgment. We can say, speaking for myself, I think, okay, but we certainly shouldn't avoid, it's an established scientific fact that. So there's a fine line here to be walked. I think we have to be less dismissive of unscientific or non-rational value systems as we might see them. And believe me, this is very hard for scientists, okay? But there are a lot of people who live their lives by what we would call unscientific or non-rational value systems. And as we've learned, those people vote. But I think we should be assertive in countering threats to the integrity of science. And I'm going to give you 4 sub-bullets here, 2 of which are things that we should be assertive to the outside, and 2 of which are we should clean up our own act. So here's one to the outside. We should do more calling out of these merchant of doubt campaigns when we identify them, and not pretend that they don't exist. There's plenty of investigative journalism on each one. And, very often scientists read that stuff and, oh, I don't want to touch that. I don't want to be dragged down into the mud on that. Now, internally, I think, and here again, I think journals could make a lot of progress here. I think we need more meaningful disclosure of funding sources of science. So most journals require funding sources to be, but it can say the XYZ Foundation. And then you can look up, any foundation's tax return, and you can find out that the donors are not identified. Now the journal could say to the scientist, sorry, we can't publish your paper unless your sponsor identifies their donors. The scientist would say, I don't know who they are, I can't do anything. Sorry, we can't publish your paper then. Because I think you could then put a lot of back pressure on the scientific enterprise to only accept support where the donors are identified. Notice, I haven't said they have to be good donors, Republican donors, or Democrat donors, or anything. I just say they should be identified. Okay, so I think we could do that. I think that with journalism, right, there's this wonderful term meretricious balance, which you know as there are 2 sides to every issue, where basically bad journalists write stories with meretricious balance. And I think we should call that out. I think we should be writing letters to the publications saying there aren't really the 2 equal sides to this story. Now, what's going to happen? The other side is going to write in also. Still, we have to do this. Okay, and then another hard one is I think that we have to do more criticism of poor quality science, even when it supports the green column, our values. Because I opened the pages of, I was president of the AAAS, whose flagship journal is Science Magazine. So during that time, I really did read Science Magazine generally. It's one of the 2 premier science journals in the world. I would say in every issue, I could find a paper that, well, it might be true and it might be false, but it's pretty clear that if it had come to the opposite conclusion, it wouldn't have been published. Okay? Just because it was an irresistible finding. It supported our value system. It was just a wonderful piece of scientific work, except it just wasn't that good. Okay, but that's what I thought. Obviously, the editors of Science didn't think that. And I think this is very important because I think that it's the poor quality science that in the end opens us up. Not all science is equally great. We should accept that. So this is my last slide. I think that we're in this for the long run, and in the long run, we're comfortable with stage 2. Communicate scientific results as established by our methodology. We could do it better. We can learn, to be better communicators of science. This is the part we're comfortable with. But stage 2 doesn't work unless there's been stage 1, which is this communicate the value of a rationalist approach to decision making. It's our values. We shouldn't be bashful about them, but we shouldn't confuse them with being scientific facts. Okay? Well, we thought that we could take stage 1 for granted. And I think I've learned, I started thinking about this and talking about this a couple of years ago. And it seemed a little abstract at the time. I thought this was just a good thing to think about. But I must say the events of the last year show me that we can't take stage 1 for granted. We have to be out there working on that in a way that we haven't before. And that's my message. So thank you. I'd love to hear your thoughts.
Thank you very much. So we have time for some questions. Does anyone have a question right here on the third row?
In your slide of methodology, you have the line saying that we assume that the natural laws are rational. That's a
Let's see. Well, I assume
agree that-
underlying natural laws.
underlying natural laws.
Yeah. We don't believe that?
I didn't say I don't believe in it, but I think it's an assumption. It's
Yeah.
our belief. It's not something that is proven.
Yeah, I agree with that. But this is our methodology. We follow these rules and some others, and we have 120 years of success at GDP growth. So,
Maybe if you would consider the other option, you will reveal other things too. Antimatter.
Walter.
Probably the most significant public debate today about science has to do with are humans able to control the temperature of our planet? And I have two questions for you on it. Where did you come up with the 87% number of scientists here that in fact believe that? It was on one of your charts.
yeah.
And secondly, why did not the global warming alarmists adhere to the policy and procedures that you kind of recommended here going through?
Yeah. Okay. I'm not responsible for the 87%. That was a Pew poll taken with some, you know, the way they do polls. I mean, they're a careful polling company, and they did that poll. The second question was?
The question is, why does not the movement that's towards
Yeah.
humans controlling the temperature of our planet, why don't they adhere to the kind of discipline that...
Yeah. Okay. I think you're outing me on the fact that my last point on this slide is directed not against climate science today, but I think in its early years, like any new discipline, climate science had some very uneven quality. I think it then came under political attack while still immature as a science, and I think they circled the wagons and they decided, I'm not quite sure who they are, right? I'm not really believing this is a conspiracy, but they felt we can't admit to any chinks in our armor. We can't say, these are papers that are now considered well established, these are papers that are no longer believed. And I think that as a field of science, they continue to suffer from that. I think by now, as a field of science, it has matured tremendously. The quality of the work has increased tremendously. And I think it's, more importantly, science is hugely self-correcting in terms of getting to the right answer. So I think the answers that are reported as the climate science consensus are very, very likely to be true. And in fact, the reports try to assign probabilities to those things. I'm not sure, as a sometimes statistician, I'm not sure I believe the exact quantification of those probabilities. But
some scientists have gone over into the value judgment direction and mixed. There's a perception they mixed the science.
Absolutely, and I think they're entitled to go over into the value judgment, but I wish that we teased those apart more carefully in communicating with the public.
Good luck.
We'll go over here and then I'll come.
Yeah.
So you mentioned that one part of, a good goal for scientists is to not only communicate our results, but also communicate the value of rationalism to people who may not appreciate it as much as we do. My question is, I totally agree with that, but my approach to that would be to use rationalist arguments, or rational arguments really, to espouse rationalism to people that don't necessarily hold rationalism. And basically, I'm trying to use rationalism to convince people of the rightness of rationalism.
Yeah.
I don't know, is there a better approach?
Well, I mean, I think there's some class of people for whom you should show that rationalism makes more money than irrationalism, right? I mean, some people will be able to be convinced, others not. By the way, I think education, especially early education, is so important here because I think, it's been said many times and it's become true. Right. Children are natural scientists. Children are curious about things. They believe evidence when they see it. I think that if we can get children started thinking that rationalism is not just an unconscious thing, but an identifiable approach to life, I think that that's an important direction.
You go all the way back and then we'll work forward, please.
I was asked to serve just this week on a panel about immunization. That's my area of expertise. And I found out there were 2 anti-vaxxers on the panel, and I declined to serve. And I found that other people had been asked and declined. But my fear is that leaves only one side of the story then.
Yeah, I don't think that's a question. I think that's just a very perceptive comment. I mean, with Neil standing here, this has not happened to me and it won't happen to me. Imagine the position a scientist will be in when he or she is asked to be Trump's science advisor. Right? We're going to see how that comes out.
I think from a public view, and you mentioned some of the remedies to it, is that there's a lot of junk science out there. I sarcastically say, tell me what you want to prove, and I'll get you the data to back it up. So the public gets confused because you see these 2 divergent things. It's like, so they don't believe anybody or trust anybody. You mentioned some steps here, but to me it almost seemed like you have to have a UL equivalent that says this has been peer reviewed, it's gone through the scientific process. Yeah. And then you've got over here the opinion side. I mean, do you see any impetus to?
But it can't be the man in the white, the old white male in the lab coat pointing his finger at you. Right. So I agree. That's a problem we have today. Who are the right spokespeople of science? The National Academy of Sciences, which just within the last year elected its first female president, Marcia McNutt, who's done a great job so far, is trying to put together short one-page things on areas of science which are, in the view of scientists, proved beyond question. Now, nothing is ever literally beyond question, okay? And trying, kind of as you're saying, at least put a baseline on it, at least put a baseline saying, these things are just not fruitfully debated anymore, whereas there's plenty of science that is in process that could be debated. I don't know if that'll be successful. I don't know who will read these things.
Question here, and then I'll come back.
Yeah, the question I've got is, there was a lot of discussion around fact versus value. What do you see as the drivers for values and value development? Because it seems that science is very driven by methodology and facts. What are the drivers for value?
Well, I don't know if I completely agree with your premise. I think I don't know many, if any, scientists who would be scientists if it was only the methodology side. I think, maybe your question is, why are those 2 sides so intertwined in the people who actually are doing science? Because my observation is they are very closely intertwined. They're just not the same as seen by non-scientists in the public.
I guess my question is more geared towards the non-science value-driven aspect.
Yeah.
So what do you see as the drivers between, where are the opportunities for the general public to influence value development versus science?
Yeah, well, I have no special expertise on that. I would say the education system. I would say parenting and how we communicate norms about parenting. Where we draw, what lines we draw between what's in the family versus what's in a larger public discourse, where vaccination is a good example. I don't know a magic bullet on that. I hate to go out on such a negative note. We might lose this battle. I invite you to, as you lie on your back at night in the dark, think about what a world will look like if this is like a sci-fi story, if it inherits our technological development but becomes fundamentally non-rational in its policymaking. Okay, I think one could actually imagine such a world. I think it would be pretty awful in a lot of ways. I think its economic progress would also be incredibly stunted.
I think this is, we're here. We are there right now. Mm-hmm. We are there. Mm-hmm. That's my opinion.
Yeah. I don't know how you're allowed to be apocalyptic in the back, but I don't think I should be apocalyptic in front.
The observation goes and the reporting goes, I think we're there. Absurdity, I agree with Al, my buddy Al Franken. Absurdity is just totally ridiculous, but that's beside the point. I just wanted to try to correlate this basic premise of value system versus methodology into an MRI or some brain imaging study, and just propose the question, which I am sure, being a computational biologist, you will most likely say, that's a good idea, let's do it, or, let's agree.
Well, okay.
Gray mapping
Yeah.
and saying, just making the hypothesis.
Yeah, there are people, I would say a field of science even less developed than climate science in its early days, but it is a field of science, are the people who, the cognitive scientists who try to correlate things like values with things like the brain.
Brainstem, values.
Let's come back in 50 years and see if they've made a lot of progress on that. I hope they do.
Anyway.
Neil is picking. Yeah.
Here and then over there, please.
I would say that 80% of Americans could not understand your talk in any meaningful way. What number would you pick?
Oh, I'd say only 50%. I don't know. I think the public is. This is one of those "do you have faith in democracy" questions, right? Which is not a scientific question. I think the public is more sophisticated than we give them credit for, even if they don't speak with the same vocabulary that we, in the certainly 1% of education, speak with. I think that's part of what happened in the last election. That a lot of the public knew what they wanted, and what they wanted didn't look like our value system. But that's politics.
Well, I said they don't understand it.
Yeah. Okay. I take your point. No. Thank you. I take your point. The woman back there.
Did you want to take a question?
Yeah. The woman there. Yeah.
Okay.
Yeah. She had it for a long time.
I'm a PhD student here at Rice, and I was wondering, kind of going back to one of your original points about going through history and some kind of catalyst, or basically a horrific event or some event has to happen. And I was going to ask, so what should we do before that horrific event happens? Do we always have to wait until the horrific event happens, and then it's kind of like, well, we told you so?
Yeah.
Or is there something that we can do to tell people, hey, this horrific event might happen? Like, I guess, what can we do in the meantime before we reach absolute catastrophe?
Yeah, I wish I knew the answer to that. I think it depends on exactly which event you're in, which area you're in. So I think that's just the right question to ask in any given area, but I don't have a magic answer to that.
Last question.
Okay.
Yeah, you've had this slide on for a while, so I've been reading it.
That's dangerous for me.
I know. So regarding that last statement there, more criticism of poor quality science, you mentioned something about being critical of the irresistible finding. That is the one work that made it to a publication. I am concerned about the good work maybe that didn't make to that publication because it didn't really
Yeah.
reflect the values, you know, can you go against that? Is there anything other than peer reviewing that takes care of making sure it includes everything that's good?
Yeah, so publication bias, as it's called, is recognized, it's studied, journal editors are aware of it. It's very hard to know what to do about it. I've always thought, for example, you know, so let's take a narrow area of real science, biomedical science, where negative findings are almost never published anywhere. Okay, only positive findings are published. So I've always thought, you know, there ought to be some foundation somewhere brave enough to, you know, it wouldn't be a paper journal nowadays. It would be an archive where if I have a graduate student, I probably assign them 3 or 4 experiments that don't work out before they hit one that does work out and becomes their thesis. Well, those 3 or 4 ought to be documented and archived somewhere, even if they don't meet peer review standards of a finding, just so that we know that somebody looked at them somewhere, so that we can say, okay, when there is a positive finding, is it publication bias or is it real? So I think there are things one could do there, but I agree with your implication. We're not doing much.
So Bill will be here for another 10 minutes. Bring down any further questions. We really appreciate your attendance, and thank you
Thank you
so much.
Appreciate it.